So we are going to discuss now about quantum numbers. There are many atomic orbitals present in an atom, and these atomic orbitals are distinguished by their size, shape and orientation. Now these atomic orbitals are distinguished by three quantum numbers, n, l and m. So let's study in detail what is these quantum numbers n, l and m. So we are going to see about the quantum numbers. The first quantum number is called principal quantum number, denoted by small n. Now, what information you get from this principal quantum number? Principal quantum number helps to find the size and energy of the orbitals. Now, we know that as n value increases, the size and energy of orbitals also increases. So, the information that we get from the value of n, principal quantum number, is about the size and energy of the orbitals. Now, this principal quantum number also helps us to identify the main shell in an atom. So, let us see what are the values of n. The values of n are 1, 2, 3, 4, etc. And I told you, by looking at the n value, you can also predict the name of the main shell present in the atom. So, next I am going to write what is the name of main shell. If n is equal to 1, the main shell is K, n is equal to 2, main shell is L, n is equal to 3, M and 4, N, etc. So, you have to study only the first 4 main shells, K, L, M, N, and you know n is equal to 1 is K shell, L is n is equal to 2, M, n is equal to 3 and n is small n is equal to 4. So, these are the informations that you get from the n value. N value means principal quantum number. It helps us to give us information about the size and energy of the orbital, and also it helps to identify the main shell. And you know, as n value increases, the size and energy of the orbital also increases, which means the orbital close to the nucleus has smallest size and smallest energy. Okay. Now, next quantum number is, the second one is Azimuthal or subsidiary or orbital angular momentum quantum number, and this is denoted by small l. So, this is the second quantum number, azimuthal or subsidiary or orbital angular momentum quantum number, denoted by small l. Now, what information will this L give? They give information about the three-dimensional shape of an orbital. But you will learn about the three-dimensional shape of orbital only in the next video. But we get many other informations from L, that is our azimuthal quantum number. So, let us see what are the values of L. Values of L. Now, L value depends on n value, that is principal quantum number. So, I am going to give the values of L. For a given value of n, L can have n values ranging from 0 to n minus 1. I will repeat it again. For a given value of n, L can have n values. So, if n is equal to 1, Then L can have n values means how many values will L have? One value. And what are those values? Those values range from 0 to n minus 1. Values range from 0 to n minus 1. So, if n is equal to 1, L can have one value, and what is that one value? It ranges from 0 to n minus 1. So, 0 to n is 1, 1 minus 1, 0. So, only one value, and that value of L is equal to 0. See, these are the values of L. So, for a given value of n, L can have n values ranging from 0 to n minus 1. Now, again I am going to write, I am going to draw a table here. The first column in the table is n value, second column is number of L values, third column is that value of L. So, first let us give n is equal to 1. We know that n values start from 1. So, n is equal to 1. A number of L values. So, for a given value of n, L can have n values. So, how many values does L will have? Only one value. And the value of L ranges from 0 to n minus 1. So, tell me what is that value 0 to n minus 1? It will be 0. Now, if n is equal to 2, we have how many L values? 2 values. Now, what are those values? It ranges from 0 to n minus 1. So, we have one value as 0 and 2 minus 1 is 1. So, these are the two values of L when n is equal to 2. Now, when n is equal to 3, we have 3 values for L. What are those 3 values? 0 to n minus 1. So, 0. Then, next we have 0 to n minus 1. So, 0, n is 3. 3 minus 1 is 2. So, we have 0, 1, 2. These are the 3 values of L. Now, last we have n is equal to 4. N is equal to 4, we have 4 values for L. And what are those 4 values? 0, 1, 2, 3. Because 0 to n minus 1, 4 minus 1 is 3. So, 0, 1, 2, 3, 4 values. Now, next, you know that if you know the n value, you can identify the main shell, Chem11. Now, inside the main shell, we have subshells or sublevels. So, we have inside the main shell subshells or sublevels, and each subshell is assigned L value, azimuthal quantum number value, and the number of subshells in main shell is equal to value of n. Okay, so what did I say? Inside the main shell we have subshells, and each subshell is assigned L value. So if you know the L value, we can assign, or we can say what is the subshell present in it. And the number of subshells in the main shell is equal to the value of n. So if n is equal to 1, we have how many subshells in it? 1 subshell. N is equal to 2, we have 2 subshells. N is equal to 3, 3 subshells. N is equal to 4, 4 subshells. Then I told you the subshells can be assigned L value. Let's see how it is done. Now, L value 0, 1, 2, 3, 4. Now, the name of subshell. If L is equal to 0, the name of subshell is S. L is equal to 1, P, 2D, 3F, 4G. Now we need only S, P, D and F, and remember all these are small letters. So these are the names of subshell. L is equal to 0. If you see the L value, you can say which subshell is present. L is equal to 0 means S subshell, 1 P, 2 D, 3 F and 4 G. Now again I am going to draw one more table, and the table has the columns headed by N, second column headed by L, third column number of subshell. Number of subshell is given by the value of N, and the fourth column we have the name of subshell. Name of subshell is assigned with the help of L value. So these are the columns. Now again I am going to write N is equal to 1. If N is equal to 1, L is equal to 0. So number of subshell is equal to value of N. So 1 subshell. We have only one subshell in the main shell K. Now name of subshell is given by the value of L. We have L value is equal to 0, and we know if L is equal to 0, it is S subshell. So the name of subshell is S subshell. Now N is equal to 2. We have L is equal to 0, 1. So the number of subshell is equal to value of N. So 2 subshells. And what is the name of subshell? Name of subshell is given from the value of L. We have L is equal to 0 and 1. So name of subshell is S, P. Next N is equal to 3. N is equal to 3 is L is equal to 0, 1, 2. So number of subshell will be 3 subshells, and name of subshell will be S, P, D. Now next is number 4. N is equal to 4. We have L is equal to 0, 1, 2, 3. We have 4 subshells, and what are the names of those subshells? S, P, D, F. So these are the subshells and its name, the number of subshell and its name, if you know the N value and L value. Okay, so these are the informations that we get from azimuthal quantum number. The main information is it gives us information about the 3D shape of orbital, which I told you we'll learn later. Now, inside the main shell we have many subshells or sublevels, and each subshell is assigned L value, and the number of subshells is equal to value of N. And L is equal to 0, S subshell, L is equal to 1, P, 2, D, and 3 F, S, P, D, F subshells. Okay. Now next, third quantum number. Third one is magnetic quantum number. Denoted by small m. Now, magnetic quantum number gives information about the spatial orientation of orbitals with respect to a standard set of coordinate axes. So, I told you these orbitals have directional property. So, by looking at the magnetic quantum number, we can identify the number of orientations possible for the orbital. Now, let's see what are the values of M. Values of M. Now, value of L was based on value of N. Now, value of M is based on value of L. So, I am going to say the values of M. For a given value of L, M can have 12 plus 1 values. So, the number of values is 12 plus 1. Okay, and the values are from minus L to 0 to plus L. So these are the values. Okay, so for a given value of L, M can have 12 plus 1 values, and the values are from minus L through 0 to plus L. Now for example, if L is equal to 0, how many M values you can have? 2 into 0 plus 1, which is equal to 1. So we have one value for M. Now what is that one value? It ranges from minus L through 0 to plus L. L is equal to 0. So minus L means 0. 0 to 0. So what is that value? The value is equal to 0. Now L is equal to 1. Suppose L is equal to 1. Then how many values we will have for M? 2 into 1 plus 1, which is equal to 3 values for M. Now what are those 3 values? It ranges from minus L through 0 to plus L. So we have L is equal to 1. So minus 1 through 0 to plus 1. So these are the 3 values of M if L is equal to 1. Now again we told that in a subshell, main shell we have subshells. Now inside the subshell we have orbitals. Orbitals, and the name of the orbital is same as name of subshell. Okay, so you know the names of subshells, S, P, D, F. So what's the name of orbital in S subshell? S orbital. What's the name of orbital in P subshell? P orbital. D subshell? D orbital. F subshell? F orbital. Now the number of orbitals in a subshell is given by the value of 12 plus 1. So number of orbitals is given by 12 plus 1. And one more thing, number of orbitals is equal to number of ways in which they are oriented. So I'll repeat this again. Inside the subshell we have orbitals, and the name of orbital is same as name of subshell. And the number of orbitals in a subshell is given by the value of 12 plus 1. Okay, and number of orbitals is equal to number of ways in which they are oriented. So I'll write it here. The number of orbitals in a subshell is equal to value of 12 plus 1, and number of orbitals is equal to number of ways in which they are oriented. So again I am going to draw a table and fill it. The table we have L value, then number of M values. Number of M values is given by 12 plus 1. Now the values of M minus L to 0 to plus L. Now next, name of subshell. Now next column we have the number and name of orbital, and the last column we have number of orientations. So these are the columns. That is L value. From L value you can write the M values, the number of M values. Then you have name of subshell, number and name of orbital, and number of orientations. So L value, you know L value begins from L is equal to 0. So how many values can M have? Only one value. And what is that one value? 0. And name of subshell is given from the L value. L is equal to 0 is S subshell. Now, number and name of orbital. You know that the name of orbital is same as subshell. So, what is the name of S orbital present in S subshell? S orbital. And what is the number of orbital? Number of orbital is given by 12 plus 1 value. So, how many orbitals? 1 orbital. 1 orbital is present in S subshell, and what is the name of that orbital? The name is S orbital. Now, number of orientations. So, you know that the number of orbitals is equal to the number of ways in which they are oriented. So, we have only one orbital means how many orientations are possible? Only one orientation. Now, next we have L is equal to 1. How many values? 3 values. And what are those 3 values? Minus 1, 0, plus 1. Now, name of subshell is P, because L is equal to 1 is P subshell. Now, number and name of orbital. Number of orbitals is equal to 12 plus 1 value. So, we get 3. So, we have 3 orbitals. And what is the name of the 3 orbitals? It is called P orbitals. And what is the number of orientations possible for a P orbitals? 3 orientations, because number of orientations is equal to number of orbitals, or number of orbitals is equal to number of way in which they are oriented. Now, next we have L is equal to 2. So, 2 into L plus 1, 5 values for M. And the 5 values are minus 2, minus 1, 0, plus 1, plus 2. Now, L is equal to 2 is D subshell. Now, how many orbitals? 5 orbitals, because the number of orbitals is given by 12 plus 1 value. So, 5 values. So, we have 5 orbitals, and the name is D orbital. And the number of orientations is same as the number of orbitals. So, 5 orientations are possible for D orbital. Now, next we have L is equal to 3. So, 3's are 6 plus 1, 7 values for M. And the 7 values are minus 3, minus 2, minus 1, 0, 1, 2, 3. Now, the name of the subshell is F. So, 7 orbitals, and the name of 7 orbitals are F orbitals. And how many orientations? 7 orientations. So, if you look at this table, you can predict the number of orbitals present in a subshell. So, I will repeat it again. S subshell has only one orbital, that is S orbital. And how many orientations are possible? Only one orientation. P subshell has 3 P orbitals and 3 orientations are possible. D subshell has 5 D orbitals in it and 5 orientations are possible. F subshell has 7 F orbitals and 7 orientations are possible. Okay. Now, again I am going to write it with the help of L subshell and another table. I am going to draw L, zero, 1, 2, 3 subshell. We have subshell S, P, D, F, and next we can write the orbital, number of orbitals. S has 1, 3, 5 and F subshell has 7 orbitals in it. Okay. So, this table, if you know the L value, you can write the name of subshell and you can also predict the number of orbitals. So, if you look at this, number of orbitals in S subshell is 1, number of orbitals in P subshell is 3, D subshell 5, F subshell 7. So, or s orbital can have only one orientation because number of orientations is equal to number of orbitals. P has 3 orientations, D has 5 orientations, and F has 7 orientations. Now, next, if you know the n value, so for a given value of n, you can write, if you know n value, you can predict the number of subshells. Number of subshells in nth shell is equal to n. Then number of orbitals in nth shell is equal to n square, and maximum number of electrons in a shell or subshell is equal to 2n square. So, these are the 3 informations that you get if you know the n value. So, if you know the n value, number of subshells in main shell is equal to n, number of orbitals in nth shell is equal to n square, and number of electrons in a shell or subshell is equal to 2n square. Okay, so with this we complete the 3 quantum numbers, that is n, l and m. Thank you.